Hello, math lovers. Today we're going to jump inside our book. We love our Ron Larson book. This is the Algebra and Trigonometry book that we'll be using this semester, this year. I'm going to start on page 2, and I want to talk about some of the sets of numbers that we have. Ron's got this beautiful chart in the textbook, and this is what I want you to think about. All the numbers that you guys have thought about up until this point are real numbers, okay? I could go a little bit further, and gosh, if I could write in my book, I would make another set of numbers up above, and I would say complex numbers, and I would break that into two parts. Complex numbers are either real or they're imaginary. We're not at the imaginary part yet, so let's just focus on real numbers. So let's start with real numbers and their properties today. So my first set of numbers I have are reals. Those are all the numbers that you can think of in the whole wide world right now. We can break those real numbers into rational or irrational. Rational, remember, you can write as a fraction. Irrational numbers you can't, like pi or root 2 or root 7. We can break our rational numbers down into integers. Those are numbers that are whole numbers or their opposites. And then, of course, non-integer fractions, like 2/3. Okay, and our integers we can break up into two different parts. We can break them into negative integers or whole numbers. Whole numbers would be 0, 1, 2, 3, 4, 5, and so forth. We can break our whole numbers down to natural numbers and 0. Natural numbers are also called counting numbers. I like to call them counting numbers. If you ask a child to count, they're going to start with number 1. You know, that's a counting number. So those are the natural numbers. So you should know your sets of numbers. I know this is complete review for you. I'm expecting that is nothing new. So as we talk about the vocabulary in this course, that's something that I expect from you. What I do want to talk about is inequalities. And this textbook does tend to graph a little bit differently than maybe you did in your previous algebra classes. Either way is fine with me, but I want you to be really, really comfortable with what you see in our wonderful textbook. Our inequalities, our numbers are ways that we can order values. So we're talking about our less than or equal to, our greater than, are greater than equal to, or are not equal to sign. And there are a couple different ways that we can go ahead and show our reader our answers. We can go ahead and we can graph them. All right, so I'm going to start really, really easy here. Like if I have x is less than 3, right? And I said to you in Algebra 1, I said, hey, I want you to graph on a number line x is less than 3. So of course you're going to put 0 in, you're going to put 3 in. It's all the points that are less than 3, so you're going to go ahead and you're going to do some shading. And you're going to go up to 3 and not include it, so you'll put a open point on that, right? So that's what you would have done last year. Or maybe I say x is less than or equal to 3, and you're going to do the same exact thing, you know, except now you're going to use a solid point, and you're going to shade all the numbers that are less than in there. Some kids draw the shading right above the number line. I was always taught to do it right on the number line. You know, that some of them have them like hovering in space. Not really sure why, but you know, it's make sure you're using whatever your style. Make sure it's very clear to your reader. You're not just making up your own style of graphing. Here, if I have 3 is less than x, which is less than or equal to 7, yeah, we've got one of each in here. You're talking about the points that are between 3 and 7, so not including 3, but you are including 7. And you're going to make a little barbell here with your graphs, okay? Now, this is what you did in Algebra 1. Our textbook, Ron, does not use this method of graphing. He uses what you're going to use in your calculus courses. And this method of graphing is going to have, well, just brackets and parentheses, all right? So if I draw 3 number lines here, so I have 0, I have 3. I want to go up to 3, but not include 3. So instead, he just uses a parenthesis, and then he shades it in here. This is the way you're going to see it in most of your higher level classes. Here in this one, you're going to include 3. So you're going to say, hey, I'm going all the way up to 3, and I'm going to include it. I'm going to use a square bracket. All right, so that's that. Not a big deal. And then here, this is between 0 and, between 7 and 3. And I'm going to include 7, but I'm not going to include 3, and I'm going to go ahead and I'm going to shade between them. So those of you guys that are messy like me, this is a good task for us, a good challenge. so that we can, we really have to be neat in our graphing, whether it's a square bracket or a round bracket. We have to show our reader. There's another notation which I just love. That's called interval notation. All right, an interval notation is a shortcut, and mathematicians, we love shortcuts. Okay, so interval notation. So we're saying to our reader, hey, where are my answers? Where are my answers to this set? And you would say, hey, Glennon, they're between 3 and 7. So you're going to have 3 and 7. So you're going to tell me, hey, I'm not going to include 3, but I'm going to include 7. So I'm going to use a square bracket on the 7 and a round bracket on the 3. This is way faster than drawing your number line, shading it. Okay, so this is a nice shortcut for us to use now that you're in Honors Algebra 2. Similarly, we're going to do the same thing for our graphs here. Our endpoints for this one, our endpoint was a 3, and we're going to include it, so I'm going to use a square bracket. And in this one, our endpoint was 3, and I'm not going to include it, so I'm going to use a bracket. But here's the problem with these are unbounded. So where am I going to go? Well, I'm going to go as far as I could go, and that takes me to infinity. So negative infinity is my endpoint for both of those. Now here's the kicker. You can never capture infinity, okay? You can never capture it. You can always go one more or one less. So as a rule, we just use a round bracket anytime we're working with that, okay? So that's the only new part that I'm adding for you. There is the interval notation is new for you, and the round and the square bracket. So there are two things I'd like us to do on page 9 and page 10 and page 11. I want you to check out the properties, okay? The properties are all review. You should know these. These are the properties for real numbers. And then there are problems for you to do on page 14. There are problems that go with that. They are numbers 101 all the way to numbers 112. Okay, so those are part of your problem set today. If we're together, we're going to do those together. And I also want you to check out the vocabulary. Okay, the vocabulary. They are numbers 1 through 10 in your textbook on page 12. All right, so the last thing I want to point out to you today is a great resource that we have in our Ron Larson textbook series, which we use for our honors courses. If you take a look at page 12 here, and at the top of every single assignment, it's going to tell you right here. It says, see calcchat.com for worked out solutions to odd exercises. So you could go to this website. All right, suppose you're really stuck on number 13. Oh my gosh, number 13. I don't know what to do with that gigantic decimal. You go to calcchat.com and you look at it. So in this classroom of mine, your job is not just to do the assignment. Your job is to do the assignment and check your answers. That way, when we're back together again, live, we are streamlining the process, all right? We are spending time on our problems. We are not going through and go, oh, I forgot a minus sign. All right, remember, practice makes permanent. Practice does not always make perfect. Perfect practice makes perfect. That's a mouthful for you. But seriously, I want your job each night, each problem set, is that you are to check your answers as you go. You do number 1, you check number 1. You do number 3, you check number 3. You do number 5, you check number 5, and so forth. So by the time you get to number 30 or 31, you have aced all the problems ahead of that. And when you've gotten to the most difficult problems of your problem set, you know exactly what you're doing. And that's my I'm a little bit different than other teachers in that session. So when we come back together and we talk about homework assignment number 2, you're going to have your questions for me, and you're going to say, hey, I tried number 27, and gosh, I checked CalcChat and I did it a different way. What do you think? And then we can talk about it, have a much better conversation than, can you just do number 27? That's boring. Okay, have a great lesson.